Experiment title JK Flip-Flop. Today's session will discuss how to simulate the JK flip-flop using Quartus 2. First, click on the Quartus 2. Open. Quartus 2 window is opened. Click on File, New Project. Check these details. Now path to be chosen. Select the path name, the directory name, then the project name to be given. Now you have to create a new folder. Folder name can be the same as the name. File name, experiment name you can give. You can give your own file name. I have given ADE JK JK flip-flop. Open. So give the name of the project, same name, ADE JK. Next, the same file name again, ADE JK. Next, check the family name Cyclone, then the package, all that, say next. Now we have to create a new file. File, new, select VHDL file where you are going to type the code. Now you can write the program. So VHDL code to simulate JK flip-flop. So entity name should be same as the file name. So it is ADE JK to be given. Same entity name should be used at the termination of entity block end followed by entity name. Same thing in the architecture statement, architecture name of entity name is. Check the program J and K clock are defined as input where Q is buffer. Thus Q is used as an input as well as output. So save the program. Now you can compile it. Compile. So compilation report is going to be generated if the compilation is successful. Otherwise, if there are any errors will be displayed. Which line, which error, you can go back to the code and then change the program accordingly, then save it. Again you have to compile. So once everything is fine, get file compilation was successful. Next one, you need to generate file new vector waveform file, say okay. So now edit end time, set the value, time period some 10 nanosecond, say okay. Now you have to set the value, click on the name, insert node bus, check the node list, JK clock everything, all this, say okay. Now multiple items are taken, now say okay. Now you can give the values, click on clock, right click, then value, select clock, use some time period here, say 1 nanosecond. Next time for J, again right click, set the value, clock, this time I'll give 2 nanoseconds, say okay. Next same way, click on K, right click, set the value, choose the clock here, you can set the value, some delay has to be generated. Last time 2, this time you can give even 1 or 3 nanosecond. So now all the 3 inputs are set now. Edit, now save the waveform. So ADE JK waveform file is generated. Now again you have to set the time, edit end time. Same time 10 nanosecond is set for the waveform file. Then assignments. Then choose functional block. Say okay. Go to processing. Generate functional simulation netlist. So you should get the functional simulation netlist generation successful. Next time, processing. Now you have to compile, start compilation. Once again, you are compiling the waveform file. Both the code and the waveform are going to be checked. So waveform is generated based on the code, based on the statements executed in the architecture block. So compilation is successful. Next, you have to start compilation as well as simulation. So simulation report is going to be generated. So once the simulation is successfully done. So both the compilation and simulation is successfully done if everything is fine. Yes, compilation simulation is successfully done. See the waveform. So this is a waveform generated. So when clock is low, J KR0Q is also 0. When clock is high, based on the value of J and K, you have to get Q here. Check it. So you need to check the results with respect to the truth table and the state boolean expressions what you have used. You can check the next values also. In clock 0, J1, K0, again Q is 0. We'll check for K equal to 1. See clock high, J high, K high, therefore now Q is also high. So based on the values of J, K and clock, whenever clock is high only you are getting Q as high. That based on the J and K values. So these are the waveforms of time. Thank you.